Distributions are of two types, discrete and continuous. In discrete, we have three types of distribution in our S1 and S2 syllabus. Number one, binomial, geometric, and the last one is Poisson. You'll do Poisson in S2. You already have done binomial and geometric in S1. Continuous distributions. In S1, we'll do normal distribution. In S2, you'll do CRV and PDF. CRV means continuous random variable, and PDF means probability density function. Well, the word function should only be used when referring to a random variable, for example, x. For data, we should rather use curve and or graph. The normal distribution. Points to remember. This capital X means the normal variable. This capital Z means the standard normal variable. These symbols are the parameters of the normal distribution. You can call this as mu. And this one is sigma square. This mu means mean of the normal distribution. And the sigma square means variance. You can describe the distribution in this way. X follows normal with mean mu and variance sigma square. This is the standard normal variable. You can call this as Z follows normal with mean 0 and standard deviation 1. And this is the formula through which we can convert the statement from X to Z. In order to transform the statement from X to Z, use this formula. Phi. Phi means the normal distribution function. What if we have phi 0.274? You will get this value from the table or calculator. If we will bring phi here, it will become phi inverse like this. Therefore, the value of phi inverse of this number is 0.274. This is the normal distribution table. Now we will understand how to read this table for phi and phi inverse. This is the first column, second column, third column. In this column, whenever we will take any number from this column, we will multiply that number by this thing. What if we are taking 14? So we cannot add 14 into this number directly. We will first multiply 14 by this number and then we will add the result into the other number. Sorry. What if we need this probability? This is the normal distribution curve, the standard normal distribution curve. The area under the curve is 1 and this larger area is phi. So, and this small area is 1 minus phi, 1.587. This number should be here and here. So how will we get this probability through table? These are the steps. We will use these steps to get the probability of this number. Number 1, for 1.587, select the first two digits 1.5 from the first column. I mean, you need to search this number in this column. Number 2, from the second column, choose the number under the column of the third digit 8. This is the third digit 8 and under this number is this. So you have got this number. You can read this number as 1.58. But we need 7 as well, the fourth digit. Always search the fourth digit here in this column. From the third column, choose the number under the column of the fourth digit 7. which is 8. Multiply this number from step 3 by 0.0001. You need to multiply this number by 0.0001 and then add this result into this number. This is the way to read the table for phi for this number. Let me repeat this again and let me do this from the table. We need this answer 1.587. So number one, you need to search 1.5 in this column. So here is 1.5. Number two, from the second column, choose the number under the column of the third digit 8. This is the third digit 8 and choose this number. So 1.58, the number is this. Next, from the third column, choose the number under the column of the fourth digit 7. Multiply this number by 0.0001 and then add the result into this number. So you'll get this thing. I'm sorry. 0.9429 plus 0.0001 times 8. The answer will be 0.9437, I guess, which is approximately 0.944 in three significant figure. This is the way to read table for phi. You can do this from your silver calculator or blue calculator. If you have silver calculator, if you have silver model or blue calculator, you can do phi from that calculator as well. These are the steps. Number one, you need to press mode and then press 3. Then press AC button. Now your calculator will be in start mode. Then press shift, then press 1 and then press 5. You will have 4 options in your calculator, P, Q, R and so on. You just need to press the P option, the number 1, press 1. Put this number 1.587 over here and then press equal. You'll get this thing. You can try this yourself. Inverse normal. We write phi inverse for inverse normal. How to use table for phi inverse? The number should be, number one, this is the most important thing. The number should be at most 4 decimal places for non-exact values of phi inverse. And let's suppose if you are like this number is up to 4 decimal place, maximum 4 decimal place. You cannot find 5 decimal place number in the table. So this number should be up to 4 decimal place, at most 4 decimal place. Well, the number of phi inverse must be greater than 0.5 if you are searching that number in the table. If it is not, then subtract it from 1. What if you are searching for this number 0.25? Since this number is less than 0.5, so you need to subtract this from 1 and you'll get this 0.75. Now you will search 0.75 phi inverse instead of phi inverse 0.25, because your table you find, basically this is the region. See, in this region you search for phi inverse, the values of phi inverse, and see the first number is 0.5, so you can only find numbers which are at least 0.5 or more, in other words. So if your number is less than 0.5, you need to subtract it from 1 and then you can look or search that number in the table. You cannot find 0.25 in the table, you need to look for 0.75. Now this is the question. I'm sorry. Find A, this A, if this probability is 0.9072. When probability is given, then we find phi inverse. So you need to write this as phi A 0.9072. Whenever we have lesser sign, we write phi A, and this area is larger. You can understand this concept through this. If this area is greater than 0.5, then write phi. If this area was less than 0.5, then write phi inverse. Sorry, you should write 1 minus phi A. So when this area is greater than 0.5, let's write phi, because this area is larger. If this area was 0.32, then you had to write 1 minus phi A. I will discuss these things later in the properties of normal distribution. I'm just concentrating how to read the table for phi and phi inverse. I will discuss how did I get phi A here later in this lecture, inshallah. Well, since we are working for A, therefore we have to bring this phi here, and when we will bring this phi here, it will become phi inverse. To find the value of A, this means the value of Z. So to find the value of A or Z, use the table in reverse and search for phi Z, value closest to this number, which is 0.9066. Let me show you this thing. You need to find this number. You need to search this number or a number which is close to this number. So let me show you this thing in the table. 0.9072. You have to find phi inverse in this section of the table. So 0.9072, let me write this number here. Phi inverse 0.9072. So you need to search either this number or a number which is less than to this number but close to this number. Less than and close to this number. So 0.9072. 0.9072. Now this is the number. This number is close to 0.9072. We always find a smaller number which is close to this number. So this number is here 0.9066, and you can read this number as 1.32. You can write here 1.32. But see, there is some difference between your requirement and the number you just search. You search this number, so you just need to check the gap, the difference between these two numbers. And the difference is, I guess, 0. I think this should be 6, I guess. Now, after that, after finding this thing, you need to do this thing. The difference is 0.006. 0.0006. Now you need to search 6 in this section of the table. See, since you are searching for this number, so to find the value of A, use the table in reverse and search for phi Z, which is closest to 0.9072, which is 0.9066. We have done till here. For our value 0.9072, we need to add 0.0006 into this number. So that add 6. 6 means 0.0006 is required. This will be done if 1.32 is given a fourth figure of 4. This one. See, your number is here. If you search 6 Horizontally, in this row, you'll get 6 here. This is 6. And the number is 4. 6 is under 4. And this number is 1.32. So now you need to read this whole thing as 1.324, because when you will add these two, you'll get 0.9066 plus 0.0006, which will make your requirement 0.9072. This is the way to read phi inverse from the table. First, search the number which is the requirement. Either search this or a number which is close to this number, but it should be less than to this number. So we search this number 0.9066. Now take the difference of this number, your requirement, and this number you just search. The difference is 0.0006. Now you just need to find that difference over here in this section of the table. This is 6. Now check the number here. It's 4. 6 is under 4. Now read this as 1.324. So your answer is 1.324. Let me explain you this again. Since we are looking for this number, therefore we need to find a number which is close to this number. I mean, either find either this number or a number which is close to this but less than to this number. So we found this number 0.9066. Now the difference between our number, the difference between this and this is 0.0006. Now look for, search 6 in this section of the table, in this row. 6 is here. Now read this number as 1.324. This is a way to use table for phi inverse. Another example, phi inverse 0.7713. The value closest to 0.7713 in the table is 0.7704. 0.7704, 0.7713, 0.7704. This is here. Now the difference between this number and this number is, this requires the addition of 0.0009 to bring it up to 0.7713, and 9 is in the column headed 3. So 0.7713. Phi inverse 0.7713. So this number is close to this number, and a difference of 9 is required. So 9 is here. So you need to read this as 0.743. 0.743. That's your answer. I hope these two examples will help you to understand how to read the table for phi inverse. Well, this section of the table is for critical values, the commonly used values. And if you have, for example, if you are looking for phi inverse 0.75, then the answer is 0.674. So you can use this small section of the table for important values of critical values. You can say the commonly used values for normal distribution. These are commonly used values. We call them critical values in S2 in testing of hypothesis and in sampling. In S1, you can call them as commonly used values. Let's start the normal distribution. We have learned how to use the table for phi and phi inverse. Normal distribution. The normal distribution is one of the most important distribution in statistics. Many measured quantities, for example, speed, time, height, length, distance, in the natural sciences follow a normal distribution. And under certain circumstances, it is also a useful approximation to binomial distribution. You can solve the lengthy questions of binomial distribution through normal approximation and to the Poisson distribution. You'll do this in S2. I'm sorry. Well, the normal variable x is continuous. Continuous means it is used for measurable quantities, for example, speed, temperature, etc. To describe the distribution, we write x, the normal variable, this x follows normal. You can read this symbol as follows or tends to. You can read x follows to normal or x tends to normal with parameters mu and sigma square. Mu means mean and this means variance. This is the normal distribution curve for x. The normal distribution curve has the following features. It is bell shape. It is symmetrical about mu. Symmetrical means equal area on both sides of this line. This is the line of symmetry. It extends from minus infinite to infinite. The total area under the curve is 1. Excuse me. Well, this area is 1, means 0.5 is here, 0.5 is here. And area corresponds to probability. And you all know total probability is always 1. So area, this total area will always be 1. The normal curve. It is a symmetric bell-shaped curve. If a probability distribution is represented by a normal curve, then mean, median, mode, they all will be equal. I mean, here, this is mean, this is the median, and this is the mode. Because this curve is symmetrical, it's perfectly symmetrical. The peak of the curve is at the mean. See, peak is at the mean. And this is where we find the curve's line of symmetry. This is the line of symmetry. Probability density decreases. See, high probabilities are here and low probabilities are here. Very small areas here and large areas are here. So probability density decreases as we move away from the mean. When you move away from the mean on either side of this mean, probability density will be decreased. That means a small number of observations are here and here. And large number of observations are close to mean. So probability density decreases as we move away from the mean on both sides. So the further the values are from the mean, the less likely they are to occur. This means when probabilities are low, that means their chances of occurring is very small. I'm sorry. An increase in the standard deviation means the value become more spread out. I mean, this means low peaks. So an increase in the standard deviation means the value become more spread out from the mean. Values are more scattered from their mean. More values are here. This results in the curves with increasing and its height decreasing so that the area under the graph is kept at a constant value of 1. So for large values of sigma, we have low peaks, and for small values of sigma we have high peaks. Large values means more spread and small values of sigma means less variation. This means This is the normal curve. Well, IQR and range. IQR, range, sigma square and sigma. I'm sorry. All these four quantities are known as the types of spread. These are measure of spread. They all show the variation of the observations from their mean. Their small values means less variation. That means observations are more close to their mean. Means in normal distribution curve, there will be high peaks. High peaks means small values, means low variation, small variation, less variation. And their large values means more variation, means low peaks, the wider curves. So observations are more spread out from their mean. So you need to learn this concept. All these quantities are known as measure of spread, and measure of spread means they all show variation of the observations from their mean. Their small values means less variation, means high peaks. Observations are close to their mean. High peaks means observations are close to their mean. And their large values means more variation. That means low peaks. That means observations are more spread out from their mean. This means low peaks, wider sketches. See, in this curve A, this has high peak. This means the standard deviation of this curve is less than the standard deviation of this curve. This means low variation, less variation, and this means more variation. Although their means are same, but the standard deviation of B is greater than the standard deviation of A. Means more variation in B than in A. That's why we have low peak here and high peak here. Well, the area under the curve is always equal to 1, whatever the values of mu and sigma. The area under red curve and the area under blue curve will always be 1. I'm sorry. Well, the standard normal variable. This is the range of standard normal variable. This is -3 and this is 3. This area is approximately 99.9%, all nearly all. That means 1. We consider this area approximately 1. If you will observe this number 3, this number is here and curve is ending here. So perfectly exactly this is 99.9, but approximately this is 1, like 100%. 0.5 is here, 0.5 is here. This is the standard normal variable. This follows normal distribution with mean 0 and variance 1. There are clearly an infinite number of values for the parameters of normally distributed random variable. I mean, for x, normal variable means x. So for normal variable, there are infinite number of values. I told you the x curve, this curve, varies from negative infinite to positive infinite. So there are clearly an infinite number of values for the parameters of a normally distributed random variable, which means x. Nevertheless, most problems can be solved by transforming the random variable into a standard normal variable, like x into z, which is denoted by z, and which has mean 0 and variance 1. So this is the normal variable and this is the standard normal variable, and through this formula we can transform the statement from x into z. So when x is this, then z has a standard normal distribution. A standard value tells us how many standard deviation x is from the mean. Probabilities involving values of x are equal to probabilities involving the corresponding values of z, which can be found from the normal distribution table. We already have done this thing in the table. So if this is x, then if we need this probability, so we can transform the statement from x into z through this formula. And then we can just work out this value from the table. We first need to simplify this, and then we need to get this value from the table. This will become phi. Let me do the simplification. Wait a minute. So 23 minus 20 is 3. 3 upon 3 is 1. So this is very simple. So this will become z less than 1. And this will become phi of 1. And I told you I will discuss this thing later in this lecture. Alhamdulillah rabbil alamin ala kulli hal. Alhamdulillah rabbil alamin ala kulli hal. While discussing the properties of normal distribution, I will discuss this at then. And I can get this value from the table. Phi of 1. So this is 1. 1.0 means 1. So the answer is 0.8413. 0.8413. That's the answer of this number. Approximately 0.841 in 3 significant. We already have discussed this thing. X is normal variable, z is standard normal variable, this is x, this is z, and this, with the help of this formula we can transform x into z. Now we have to solve this question. X follows normal with mean 40 and variance 17, and we need this probability. So number one, we have to transform this statement into z with the help of this formula. So x is 50. In this formula, x is 50, mu is 40, and sigma is under root 17. Because this is sigma square, and we have sigma here. So it must be under root 17. Make sure you mention under root here. You have to show under root here. Otherwise, you will lose 1 mark. Now, the simplified form of this is 2.425. And this will become phi. It's here. And you all know how to get this value from the table, 2.425. Let me tell you how to get this, 2.425 from the table. So 2.425. So the number will be 0.99221. So 0.9923. In 3 significant, it's 0.992. Now, here I will discuss how did I get phi here. Properties of normal distribution. I told you the larger area, this is the larger area. This is always phi. If the larger area means greater than 0.5. If the area is greater than 0.5, then we call that area as larger area or large area. So this is the larger area, therefore this must be phi of this number, because this is the reference line. And you can write this as probability z less than a is phi a. And this is the smaller area. And smaller area means, I mean area which is less than 0.5. So this area will always be 1 minus phi of this number. So this should be 1 minus phi a. So if you need this probability, so you need this area. This probability means you need this area, and this area is a small area with respect to this area. So this area must be 1 minus phi this number, and this area means 1 minus phi, sorry, this area means phi this number. So large area is always phi and small area is always 1 minus phi. You need to learn this thing. Examples. So if you need this probability, you just need to mark this here. See, I told you this is the standard normal curve with limits minus 3 and 3. This is the curve of z, and this is 0, this is 3, and this is minus 3. Make sure you understand the curve for z. The limits are approximately minus 3 and 3. So you need the value of z. You need the probability, this probability. See, this equation has lesser sign. So first mark this line here, make the reference line. 0 is here, so 2.578 will be close to 3, and this is the reference line. You just need to assume estimate the line, estimate this value. This value is close to 3, so this value should be here. And since we have lesser sign, so we need area, left side area of this reference line. This area, this is the requirement. And since this area is large with respect to this area, therefore this area must be phi this number. You need to write phi this number. That is why I wrote phi here. See, we need this probability. So first mark 2.425. This is 2.425. This is the sketch of z. And I told you the range of z is from minus 3 to 3. And according to this inequality, you need this area. And this area is large with respect to this area. So this area must be phi of this number. That is why I wrote phi 2.425 here. And we already have learned how to get this value from the table earlier in this lecture. So this must be phi, and you all know how to get this value from the table. I will not discuss this thing now because I already have discussed this thing earlier in this lecture. So if you have any query, you can watch the lecture, the first part of this lecture again. Now, if you need this probability, 2.578, first mark this number here on the z-axis, make the reference line, and according to this inequality, you need this area. Now, this area is small with respect to this area. When area is less than 0.5, we consider that area as a small area. So this area is less than 0.5, so this area is 1 minus phi this number. This is 1 minus phi 2.578. And you all know how to get this value from the table. Number 3, we need this z less than minus 1.896. So first mark this on the sketch. This is here. The sketch of this probability is here. Now see, this area is small, and according to symmetry, I made this sketch. You don't need to make this sketch in the you're working. This sketch is fine. If you want, you can make both the sketches. I'm sorry, but this sketch is fine. The logic is why I'm getting 1 minus phi positive 1.896. Why did I write plus here? This is the logic. I first made this sketch, and according to symmetry, I made this sketch. Basically, what I did, since this is the line of symmetry, so this is the mirror image, so the mirror image of this area will be here. And this will be 1.896. So in order to get this area, the problem is the table is for these values of z, 0 to 3. Table is not for negative values of z. So that is why we have to use symmetry. Whenever we get negative values of z, we always use symmetry. We cannot find this number in table. We can find only this part in the table, 0 to this here. So we have to use symmetry. So this is 1 minus 5 negative 1.896, and this is 1 minus 5 positive 1.896. Because of symmetry, both areas are equal. That is why I wrote positive number here. I hope you have understood this. So whenever we have negative number with negative numerical value, whenever we have negative numerical value, we will always write that value as positive because we always use symmetry. So you have to learn this thing. For negative numerical values of z, always write phi positive. But one thing is very important. What if we had unknown, like unknown is here, negative unknown, then we have to write negative sign here. I will discuss this thing later in this lecture, inshallah, or in my next lecture. So whenever we have, let me repeat, whenever we have negative numerical value, then we will always write positive sign in phi because we always use symmetry. Now, this one, z greater than minus 1.896. This is the sketch of this number. Minus 1.896 is here because 0 is here, and we need this area, and this area is large, so this must be phi negative 1.896. This is phi negative 1.896. I already have told you we cannot find this in the table, so we have to use symmetry. So the mirror image of this sketch is this. So this will be, this area is also phi 1.896. That is why we have positive sign here. So whenever we have negative signs in z, we will numerical. I mean, whenever we have negative values of z, we will always write them as phi positive because we always use symmetry. If you want to take this screenshot of this page, you can. These properties are very important. You must be good at the properties of normal distribution if you want to be good at this chapter. I'm sorry. Number 5. See, we have between case. Z lies between this and this. So this is the sketch. This number is here and this number is here. See, this area will be phi 1.532. This area. And this total area will be phi 2.896. So larger area is this. This is the larger area. And this one is the smaller area. So you need to subtract this area from this area. So phi 2.896 minus phi 1.532. So whenever we have both positive numbers, both positive numerical values, then we will write phi of larger numerical value minus phi of smaller numerical value. And this is the logic. This total area is here. This is phi of this number. And from table you'll get this thing. And this area is here. This is phi. And from table you can get this. So when you will subtract these two values, you will get your answer. 0.9981 minus 0.9372. You can do the calculations later. Well, while solving question, you don't need to sketch this and this. This is for your conceptual clarity. Just this sketch is enough. Well, in property number 5, both numbers were positive. So the case was very simple, phi of this minus phi of this. In property 6, this number is positive, so this must be phi. Positive number is always phi. And negative number will always be 1 minus phi. Why? Because this negative number is here. And this area is small. So this area is 1 minus phi. So whenever we'll get negative number here, we will always write 1 minus phi. 1 minus phi positive 1.532. And the logic is here. I mean, on the left side of this line, the area is greater, the larger area. This is phi, this total area is phi, it's here. This is phi, the larger area. And from the left side of this reference line, the area is here, 1 minus phi. So you need to subtract this area from this area to get this area. So remember, when both numbers are positive, write phi for both, larger minus smaller. When one is positive and the other is negative, like this one is always negative, this one is always positive. So you need to write phi for positive and 1 minus phi for negative. In property 7, both numbers are negative. So do the opposite of property 5. In 5, you subtracted this number from this, because this is the larger numerical value and this is the smaller numerical value. This is the larger numerical value. If we ignore the negative sign of these two negative signs, then this is the larger numerical value and this is the smaller negative value. So you need to do the opposite thing of property 5 here. In property 5, you subtracted this from this. I mean, you wrote phi minus this phi. Here you need to write phi this minus phi this. Do the opposite. And the logic is this. You need this area. So on the left side of this reference line, this area is greater than this area. See, this area is here. This is 1 minus phi. And this area is 1 minus phi. So this minus this. So when you will do this minus this, you will get this equation. Let me write this here for your conceptual clarity. 1 minus phi 0.587, 1 minus phi, this is the larger area, this is the smaller area, so this minus this, 1.582. So when you will simplify this, you will get phi 1.582 minus phi 0.587, which is same as this. So whenever both signs are negative, so write phi of this here and phi of this here. Next property, modulus. You all know how to solve this modulus inequality. You have done this in art math. But since non-art math students will also, normally watch this lecture, so I'm going to explain this in detail. So just remember this thing. The result of this inequality is this. Learn this result. Whenever we have less than sign, we always write z lies between minus a and a. And this is the logic. This is the result. I strongly recommend you all learn this result. For lesser sign, write this. For greater sign, write in the other way. Like, what if we have greater sign, then write in this way. By the way, non-art math students have already done this thing in quadratics. They all know when we have lesser sign, we write the result in this way. When we have greater sign, then we write the result in this way. So kindly learn these two results. Because when you will simplify this modulus, you will get this thing. And you have done this in quadratics functions, that the result of this inequality is this. So make sure you have learned these two results, this one and this one. When we have lesser sign, then this area is required, means z lies between these two values. And when we have greater sign, then we have these two results, meaning these two areas are required. And in this case we will only find this result 1 minus phi a, and we will multiply this by 2 to get the total answer. We won't work for this area because both areas are same. So we will only work for this and we will multiply our answer by 2 to get the total answer. Here we have to work for this inequality. And here this is the logic of removing the modulus. We square on both sides in order to remove modulus. Then we need to bring this on left side of the inequality and then we'll get this thing. So these two results are very important. See this one. So z less than a, you have to write this as z lies between minus a and a. And according to property number 6, this property, one is negative, the other is positive. The positive one we write for positive phi, and for negative we write 1 minus phi. Same is here. This is positive, so this will become phi and this will become 1 minus phi. When you will simplify these two, you will get 2 phi a minus 1. For positive, you write like this: z less than minus a, z greater than a. Just get this area and multiply this by 2 to get this answer. It's here. If you want to take the screenshot of this, you can. If you need the PDF of this lecture or any other lecture, we are uploading or the links of the PDFs and lectures on Facebook page. If you find this page, Sir Muhammad Qadri. So this is my page, Sir Muhammad Qadri. You can find the PDF and other things on the page. You can like and share that page as well if you want. Normal distribution table. This table is for inverse normal here. This is here for inverse normal thing. We already have done how to use table for phi inverse. We find phi inverse in this section. So I will not discuss phi inverse thing here. I will just discuss the properties of inverse normal. How to find value of z using the given probability. This is known as inverse normal, phi inverse. This is one of the most important concept of normal distribution. So make sure you understand this concept with good concentration. Now, greater sign, when we have greater sign, for example, if we have this situation, z greater than a is 0.9. When we have greater sign, greater or greater equal, they both mean the same thing in normal distribution. In continuous distribution, these two signs mean same thing and these two signs mean the same thing. So don't worry about these things. So when we have either greater sign or greater equal sign, then we shade from upper tail to lower tail. We shade in this way. Wait a minute. Let me sketch this here. See, this is number 1 and this is number 2. Since we have greater sign, so we have to shade in this way. We have to shade the given area in this way. Shade the given area from upper tail to lower tail. This is the upper tail and this is the lower tail. From upper tail towards the lower tail. When we have lesser sign, then we have to shade from lower tail towards the upper tail. Let me write the example. Z greater than A is 0.9. So in order to shade this area, you need to start shading from upper tail towards the lower tail. So this is 0.9. What if we have to shade this thing less than A, 0.9? So you need to shade from lower tail towards the upper tail. So this total area is 0.9. This is the way we shade the given area in order to check the position of A. Why do we shade these things? Because we need to check the positions of A. Let me write this here. To decide the position of the unknown For example, A, we shade the given area according to given sign of inequality. According to the given sign of inequality. So when we have a greater sign, we shade from upper tail towards the lower tail. When we have lesser sign, we shade from lower tail towards the upper tail, so that we know the exact position of the unknown, because it's very important whether unknown is on left side of 0 or right side of 0. When it is on right side of 0, then it's positive. In this case, your unknown is positive, and in this case, your unknown is negative. And this is very important while solving inverse normal questions of inverse normal. I have mentioned this here. To decide the position of the unknown, we shade the given area according to given sign of inequality. We shade this area according to given sign of, since we have greater sign, so we shaded from upper tail towards the lower tail. Since we had lesser sign here, so we shaded from lower tail towards the upper tail. Examples. See, this is unknown. To decide the position of this unknown, we have to shade this area according to this sign. Since we have greater sign, so we have to shade from upper tail towards the lower tail. See, since this area is greater than 0.5, so we have to cross this central line, because till the central line the area is 0.5. This is 0.5 and this is 0.5. So make sure you have to cross the central line when the area is greater than 0.5. So 0.75 is this area. This area is 0.75. This means your unknown is negative. See, the unknown is negative. Same question, but the area is less than 0.5. You have to shade in the same way from upper tail towards the lower tail, but you have to stop before this central line, somewhere before this central line, because the area is less than 0.5 and your unknown is positive. That is why we shade the given area to decide the position of the unknown, whether unknown is negative or positive. Number 3, see, we have lesser sign, so we have to shade from lower tail towards the upper tail in this way, and the area is very large. This area is 0.9, so this must be here. This must be here. And your constant is here. Since area is very large, close to 1, so it must be here. Make sure your sketch must be proper. This is a proper sketch, and this is the estimated position, correct position of C, because total area is 1 and this area is close to 1, so it should be here, and C is positive in this case. Now same question is here, but the area is less than 0.5, and because of this lesser sign, you have to shade this area from lower tail towards the upper tail. Since this area is less than 0.5, so you have to stop before this central line, somewhere before this central line. So you have to stop here. I'm sorry. This 0.9 is here and this 0.4 is here. And in this case, your D is negative. You can do inverse normal from table or from calculator. If you have latest version, which is FX, this is the latest version, FX991EX. This is the white case calculator, the latest version. So you have option, if you have the latest version, you can do inverse normal from calculator. And I will discuss that thing in my next lecture, how to use the latest version of calculator for normal distribution. I will not discuss that thing here. So I'm just focusing on the table. You know how to get this value from the table. I told you for phi inverse, the number must be greater than 0.5. You cannot find this number from the table. Well, this will become phi inverse 0.4. If you are using table, you won't be able to get this value. So this is equal to phi inverse 0.6. I mean, you need to subtract this from 1 in order to get this value from the table. So you need to search 0.6 in the table, and you know how to use table for phi inverse. So I'm not discussing that thing here. I already have discussed that thing in my, earlier in this lecture. So just search this thing. And then what if whatever the value of 0.6, let me check the value of 0.6. The value of 0.6 is 0.2533. This value is 0.2533, but since your d is negative, so you just need to write minus 0.2533. I mean, neither your table nor your calculator will give you the right sign. You have to decide this negative sign from the sketch. Since your constant is negative, so you need to put negative sign yourself. So no matter what sign your calculator shows, choose sign according to the above diagrams. Your diagrams will tell you the signs, the correct signs. This number will become phi because this number is greater than 0.5, so you can find 0.9 from the table or from the calculator. If you are using your table, you can get 0.9 here. See, this is 0.9. Its value is 1.282. Since 0.9 is the commonly used value, so you can find that value in the small table. So the answer is 1.282, and according to sketch, this number is positive, so C is 1.282. I'm sorry. I hope you have understood this concept well. If you want to take the screenshots of inverse normal thing, you can. This is the first page of inverse normal. Four properties of inverse normal. Property 1, property 2 for greater signs, property 3 and property 4 for lesser signs. Now, I will solve these questions. I will discuss the solutions of these questions, in fact. Since we have greater sign here, so we have to shade area in this way, from upper tail towards the lower tail, in this way. Since this area is less than 0.5, so I have to stop well before this central line. This is 0.25. And this small area must be 1 minus phi. I told you when we have small area, then we write 1 minus phi. So this is 1 minus phi. Here I did this directly. I wrote I subtracted 0.4 from 0.6. So don't mix this thing. Let me erase this. This was fine, but maybe possible you would mix this thing. This was originally 1 minus phi, but you cannot find this area, so you need to find this area, 0.6. That is why I wrote phi inverse 0.6 here. And the answer was 0.2533. So this is the question number 1. Since this area is small, so we write small area as 1 minus phi, this number. So 1 minus phi is equal to 0.25. When you will simplify this for phi a, you will get 0.75. So this is phi inverse 0.75. And you can find this thing from your table and from your calculator. I will discuss calculator method later. If you have latest version, okay, I'm going to discuss that method now. For that you need to, number one, if you have latest version of the calculator, then you need to do this thing first. Press setup, then press 7, then press 3, and then put 0.25. In calculator, no problem. You can either put 0.25 or 0.75. Calculator has no issue. Calculator can give you any value. But in table, you can only get the values which are greater than 0.5. So this is the working through table, and from calculator, you can directly put 0.25. So I'm substituting 0.25 in the calculator, and then I have to press equal twice. I'll get minus 0.674. I'm getting this thing, minus 0.674, but this minus is not the right sign. I have to discuss this sign. I just ignore this sign. I just need to ignore this sign, and I have to decide sign according to my sketch. According to my sketch, my unknown is positive, so I have to write positive 0.674. So make sure if you are using calculator, then don't take the sign of the calculator. I have mentioned this thing here. No matter what sign your calculator shows, choose signs according to the above diagrams or according to your own sketch. This sketch says that A is positive. So you cannot write negative sign here. You have to write positive sign. So if you are using your calculator, you can solve this question in this way. Probability Z less than A 0.25. According to sketch, A is positive. So this will become phi A. This is the calculator method. Phi inverse 0.25. So this will be minus 0.674, but I have to decide sign according to my sketch, so it's positive 0.674. So this is the calculator method. I will discuss this method in my next lecture, inshallah. So I'm just focusing on table. So according to table, this is the small area. Table says if area is less than 0.5, then you need to write 1 minus phi. So when we have a small area, we always write 1 minus phi. 1 minus phi is 0.25, so phi A is 0.75 and phi inverse 0.75 is 0.674. Now this one, shade in this way, from upper tail towards the lower tail. So you need to write this as phi A 0.9, and from your calculator, from your table, you can easily get the value of this 1.282, and it's negative according to sketch. Let me write this calculation of the table. This will become phi A 0.9, so A is phi inverse 0.9. Since A is negative, so I have to write the negative value because A is negative. Next question. In this question, you have to shade in this way. So when you will shade this area, you'll get, this unknown here. This is positive. So this is phi A 0.9, A phi inverse 0.9, and just write 1.282, positive number. This is the last question of inverse normal, Z less than A. So you need to shade in this way, but this area is very small. So this must be here. So A is negative. And I told you, you cannot find this area from the table. You need to work in this way. This area is small, so you just need to write 1 minus phi A is 0.1. So 1 minus phi A is 0.1. Therefore, phi A is 0.9. A is phi inverse 0.9. So A is negative, so it should be negative 1.282. So please learn this thing. for table, small area is always 1 minus phi, large area is always phi. Always use this concept. The concept is change in calculator. So that is why I'm not discussing the calculator's concept here, because otherwise you will probably mix the things. So I'm only focusing on table. I already have discussed this thing earlier in this lecture, that small area is always 1 minus phi and large area is phi. So see, this area is small, so this must be 1 minus phi, this number, and is given 0.1. Then you just need to simplify this. This area is large, so it must be phi. This area is large area means area which is greater than 0.5. So this area is greater than 0.5, so this is considered at the large area, larger area. So this must be phi a. This area is small, so it must be 1 minus phi a. Now these things are very important, especially for bio students. And these statements, this thing, the probability is important for bio students. They'll do this thing in, I think, second year. They must remember this area. But this statement is important for everyone. This statement says within 2 standard deviation of the mean or from the mean. Of the mean or from the mean means same thing. Of or from means same. That means mu plus minus 2 sigma. And this within means less than sign. So this means 2 standard deviation from the mean means, let me write this thing here separately. Just this statement means mu plus minus 2 sigma, and within means this area. So in inequality terms, you should write this as x less than mu plus 2 sigma. Just write this thing, because when you will remove this modulus, you will get both the things, mu plus 2 sigma, mu minus 2 sigma. This one, because this modulus is removed in this way. X lies between mu minus 2 sigma and mu plus 2 sigma. So whenever it says 2 standard deviation or something like that of the mean from the mean, that means mu plus minus 2 sigma. And in modulus term, it should be modulus x less than means within, and mu plus 2 sigma is here. And you can remove this modulus like this. Well, this means within 3 standard deviation of the mean. So this means mu modulus x mu plus 3 sigma. You can simplify this yourself in the same way as I did here. This means 1 standard deviation of the mean, mu plus 1 sigma. When you will simplify this, you will get this. X mu plus 1 sigma, mu minus 1 sigma. When you will convert this in this statement of z, you will get this thing, minus 1 plus 1. This is plus and this is minus. So you'll get this thing. And you know how to solve this. This will become phi 1. This will become 1 minus phi 1. I already have discussed how to solve modulus inequalities. So the final answer will become 2 phi 1 minus 1. We have discussed this in the properties of normal distribution of phi. Make sure you will learn these 3 things. For bio student, they need to learn these probabilities. For S1 student, they don't need to learn these probabilities. They just need to learn how to write the modulus things according to given statements. When it says within 2 standard deviation of the mean, write in this way. When it says within 3 standard deviation of the mean, write this way. When it says 1 standard deviation from the mean, write this way. And this is the way to simplify this modulus. And these 4 statements are extremely important. This says more than mean, like they can say 1 standard deviation more than mean, or 1 standard deviation above the mean. They can say this. If this is 1 standard deviation above the mean, for example, then you need to write this as x greater than mu plus 1 sigma. That's it. Don't write modulus here. It says above the mean. They are not saying from the mean or of the mean. Whenever they says from the mean, they say from the mean or above the mean, from the mean or off the mean, then you have to use modulus. When they say just above the mean, 1 standard deviation above the mean, just write x. Don't write modulus here. This is very important. In this case, we never use modulus. We just need this area. Now, number 2. This is number 2. More than means greater sign. 1 standard deviation from the mean. Now, from the mean means from. The word from or of means modulus. So, you just need to write this thing as modulus x. More than means greater. 1 standard deviation mu plus 1 sigma. And you know how to simplify this. Just run this thing. Use the properties of modulus. In fact, we write this number here. This is the direct method. If we have mu here and sigma here, we write this number here. But what if we don't have sigma here? Then you need to simplify this in a routine way. Like you need to remove modulus like this. In this way. See property number 8 and 9 of phi for this. When it says within means less than sign, from the mean means modulus. So modulus x less than mu plus 1 sigma. These statements are extremely important. You must understand these things. How to write the equations in modulus like this. This is without modulus and they all are with modulus. Because they are saying from the mean, from the mean, from the mean. Deviate from the mean means same thing. Deviate from means modulus. By more than 2 standard deviation. More than means greater sign. 2 standard deviation. Mu plus 2 sigma. And this 2 is here. This 1 is here and minus 1 is here. You can find the PDF of this lecture on my Facebook page. My Facebook page is Sir Muhammad Qadri. Because you must need this PDF. And these statements means this area, this means this and this area because of this sign. Within means this area, and more than means this and this area. I solved this part here. See, I did this one for you. So, when you will write this in a modulus z form, you need to write mu plus 1 sigma minus mu over sigma. Mu and mu will be cancelled, sigma and sigma will be cancelled, so you'll get 1. See, I wrote 1 directly here. That's the logic. And you need this area and this area, so you just need to write, you just need to find this area and multiply this by 2. So this is the way to remove modulus. Z less than minus 1, z greater than 1. I have already discussed this earlier in this lecture in the properties of phi, property number 8 and 9. So write this less than minus 1, this greater than 1, and just get this area. So get this one and multiply this by 2 to get this area as well. Well, 3 commonly occurring types of curved graphs are shown in the diagram. This one is symmetric. This one is symmetric. Symmetric about central line. Even tails. Let me sketch this correctly. Let me try. Not good at sketches, but let me try this. This is symmetric, approximately symmetric. I'm not good at sketches. My writing is not good, but I'm trying. So this is symmetric about the central line. Equal area here and here. This one is negatively skewed because mode is here. High peak is at this side, and this high peak is at lower side, so this means positively skewed. Skewed means non-symmetrical distributions. This has zero skewness. This has zero skewness because this is symmetric. Since these two are non-symmetric, so since high peak is at upper side, upper tail, so this one is called as negatively skewed, this one is called as positively skewed. The mode is located at the graph's peak. Here is the mode. This is mode. Mode is here. The median is at the value where the area under the graph is divided into equal parts. Maybe median is here. Because if this area is 0.5 and this is 0.5, then median must be here. But mode is here. Mode means the value of x at which probability is highest. This highest probability. This value can be found by calculation from the histogram or estimated. You don't need to get calculate median in normal distribution, but you just need to learn these diagrams. This is the mode. This is the mode. Median should be here because this area 0.5 and this, let's suppose 0.5, median should be here 0.5, 0.5. This is just for your conceptual clarity. Now the next topic of our lecture is the normal approximation. Well, the normal approximation to binomial distribution. This is the complete topic. The normal approximation to binomial distribution. You know, you already have done binomial distribution. If we have this binomial distribution, see n is very large. So if we need this probability, we cannot use direct method and indirect method for this probability. I mean, both methods are almost impossible. We have to find a lot of numbers, probability of a lot of numbers, 50 to 120 inclusive, all the numbers, which is impossible through binomial. In indirect method, again, we have to find probabilities of almost 50 numbers, which is not possible for binomial. So both methods are lengthy. When both methods of calculating the probability in binomial are lengthy, then we use normal approximation. This is the hint. Please understand this thing. See, when n is greater equal to 30, this is the hint where you have to use normal approximation. So when n is greater equal to 30, then both the methods are lengthy. Then you have to use the normal approximation. Now, what is the condition of normal approximation? This is the hint and one of the most important thing, how to use normal approximation, because in some questions this examiner don't mention you have to use, whether you have to use it or not, but you have to use normal approximation. So this is the condition of the normal approximation. Both NP and NQ should be greater than 5. If they ask state the condition of normal approximation, then must write this thing. Both NP and NQ greater than 5. And don't write this thing, this is the hint. I'm sorry. The normal distribution, you know, the normal distribution is continuous and binomial distribution is discrete. This is continuous and this is discrete. Discrete means countable quantities, continuous means measurable quantities. So in binomial, we can only have integers. We cannot find probability of 30.3 in binomial. So in normal, we can find the probability of integers or non-integers. We can find probabilities of any value of x. So in normal, we have continuous measurable quantities. We can have decimals, we can have integers, we can have anything in normal. But in binomial, we can only have countable quantities, so integers. Only integers are possible in binomial. Since we use a continuous distribution, we use normal approximation to calculate the probability of binomial distribution. Here, since we use a continuous distribution, means normal distribution, to solve a discrete distribution, that means binomial distribution, we need more accurate values to make the approximation as accurate as possible. To make the estimate, like to make the calculations, to make the approximation as accurate as possible. This is the exact method of question. I mean, if the question is of binomial and if you can solve the question through binomial, then you will get the exact answer. But if the question of binomial and you are unable to solve through it binomial, then you need to normal approximation, and normal approximation will give you estimated answer, not the exact answer. In order to make this estimate as accurate as possible or good estimate, you have to do something in the approximation. That is known as the continuity correction. So to make the approximation as accurate as possible, we do continuity correction, CC. C. For normal approximation, we use the following two steps. Number one, the continuity correction. We use this. In short, we call this as CC. What is this? This means the addition of and subtraction of 0.5 into the given discrete variable x. I mean, sometimes you have to add 0.5, sometimes you have to subtract 0.5 from x. So it depends. It depends on the given signs of inequalities. Now let's discuss where do we have to subtract 0.5 and where do we have to add 0.5. Now, for that, always use number line. In order to understand continuity correction, always use number line. With the help of number line, you can easily do continuity corrections. And whenever you go on this side on the number line, then always take the lower bound of the number. Take the lower bound, that means subtract 0.5 from x. And whenever you go on left side of the line, whenever you go on this side of the number line, the right side, take the lower bound of the x of the number. Subtract 0.5 from x. And whenever you go on this side of the number line, then take the upper bound. That means you have to add 0.5. Well, we can understand this concept through the following examples. Example number 1. This is binomial and we need this probability, x greater than 70. See, the first possible integer of this inequality is 71. You can say the smallest possible integer of this inequality is 71. So whatever the inequality is given, always take the first possible integer on the number line. This is one of the most important thing of using the number line. Listen to me carefully. Write the first possible integer value according to given inequality. In this case, the smallest possible integer is 71. The first possible integer is 71. If you will solve this question through binomial, you will start from 71. So write 71 here. Always write first inclusive integer on the number line. Now, since we are going on right side of the number line, therefore we have to take the lower bound of this number. Take the lower bound of this number. So when you will take the lower bound of this number, you will get this thing, 70.5. So you need to use 70.5. Like you have to use this probability z or x greater than or z greater than 70.5 minus mu over sigma. You will use 70.5 in the calculation. I will discuss this after the step 2. Now in here, the first possible integer is 70. If I will solve this question through binomial, the first possible integer will be 70, the direct method of binomial. So I must write this number here on the number line. Since I'm going on the right side of the number line, so I must write 69.5. I must take lower bound of this number. The lower bound of 70 is 69.5, and I will use this number in the calculation. Less than 50. The first possible integer for this must be 49 if I will solve this question through binomial. So I must write 49 here. And since I'm going on left side of the number line, therefore I have to take upper bound of this number. This is the upper bound. And I will use this in the calculation. Instead of 50, I will use 49.5. Or instead of 49, I will use 49.5. Step 2. Now the step 1 is continuity correction, and step 2 is change of mean and variance. Since we have to change both, we change the mean and variance of normal with the mean and variance of binomial because we are solving binomial question through normal. So we need to use the mean and variance of binomial here. The mean of binomial is this, NP, and the variance of binomial is this. The mean of normal is mu, so mu will be NP. And the variance of normal is sigma square, so it must be NPQ. Generally, we write normal distribution in this way. But when solving questions of binomial while using normal approximation, we need to replace mu by NP and sigma square by NPQ. And we already have discussed the conditions for the approximation. Both NP and NQ are greater than 5. This is the condition for normal approximation. Must learn this condition because examiner asks this condition. They usually ask this condition. So after completing these two steps, you can easily do normal approximation. And this is the hint, we already have discussed this, and both methods are lengthy, then we use normal approximation. And how to use normal approximation, I already have told you this thing here. Now this is the question. Now let me correct just one page. This page is wrongly here. It should be here. I was discussing continuity correction 3, number 4. This is number 4. So when we have lesser equal to 50, the first possible largest integer will be 50 because we have equal sign here. So the first number must be 50. So this number must be here. Since we are going on left side, so we have to take upper bound. You need to use this number in the calculation. Here both the numbers are inclusive, so write 40 here and 60 here. For 40 you are going here, you are going in this direction, so take the lower bound. For 60 you are going in this direction, so take the upper bound of 60. It should be 60.5. Now you need to use these numbers in calculations. 39.5 here, 60.5 here. Both the numbers are exclusive, so the first number must be 41 and the last must be 59 according to this inequality. So mention 41 here and 59 here. For 41 you are going in this direction, so you need to use the lower bound of 41 and upper bound of 59. 59.5 here, 40.5 here. I already have discussed this thing. Okay, we change mu by NP and sigma square by NPQ. This is the repetition. We already have discussed these things. So x follows n binomial with parameters np can be approximated by normal with parameters mu and sigma square, where mu is np, sigma square is npq. This is the summary. Provided that n is large enough to ensure that np and nq both are greater than 5. Continuity correction must be made when a discrete distribution is approximated by a continuous distribution. This is the summary of normal approximation. Don't forget to make the continuity correction. And this is the formula. X minus mu over sigma will be converted in this way. X plus minus 0.5 NP NPQ. We use this formula in the normal approximation. We decide plus minus 0.5 through number line, and we always place NP here and NPQ under root here. This is the example. In Scotland, in November, on average, 80% of days are clouded. This is the P of binomial. Assume that the weather on any day is independent on other days. This is basically binomial. So P of binomial is 0.8 and n is 30. Use a normal approximation. Find the probability of fewer than 25. So we need this probability. Fewer than 25 are cloudy. Cloudy means P is 0.8. So this number is exclusive. The first possible integer of this inequality must be 24. So we have to take the upper bound of 24 because we are going on this side on the number line because of this sign. This inequality sign decides where you are going on the number line. This has lesser sign, so you are going here. What if we had this sign? Then you had to go here on the number line. So whenever you go here, you take the upper bound. So I'm using this formula. See, this formula. I already have decided 0.5. This is 24.5. This is NP. And this is under root NPQ. Let me mention this here. I'm using this formula here. 24.5 NP NPQ. And after this step, the question is routine. This is the routine question. You all know how to solve this. This is phi, because this is larger area, so it must be phi 0.228. So you can write this as phi 0.228. And you know how to get this phi from table. And the second part, give a reason why the use of normal approximation is justified, because the value of NP is 24 and NQ is 6, both are greater than 5. This is the justification. This is the normal distribution table for you. You can use this. And this is one of the most important thing. Very important. This is very important. You must know how to read these inequalities. X less than A means. Well, X less than A means X is fewer or less than A. You can read this in this way. X this means X is fewer or less than A. This is simple to read. This one is also simple. This means X is more or greater than. X is less than equal to A means X is at most A, and X is, this is very important. This means X is at most A, or you can say this as X is not more than A. Or you can say this as X is A or less. Now this statement is very important. X is not more than A. Whenever they use in exam, students normally get confused. What is meant by this statement? X is not more than A. So X is not more than a means this thing, that is x is less than equal to a. Now the last one, this means x is at least a, and you can say this x is not less than a. These two statements are very important. X is not less than a means x this, that means x is greater or equal to a. Make sure you understand these statements. This is an important note regarding the inequalities. Well, I hope this lecture will help you all to understand the concepts of normal distribution well. I tried my level best to explain this chapter. I hope this will help you all. We should be honest. This is an advice for me and everyone. We should be honest. We should be well-mannered. I will discuss the I will discuss the calculator method in my next lecture. How to solve normal distribution with latest calculator. Inshallah, in my next lecture. Allah Hafiz.